Let's start with the session, and I would like to invite Mr. Saurabh sir to take the session forward. Over to you, sir.
Thank you very much for such a brief introduction. So, very good evening to everyone, right? And I hope you all have one dream to join automotive industry as a ADAS developer or some of willing to have a job in automotive, right? So, it's not like that. Getting a job in automotive is easy or hard. This is not our concern, right? This our concern is make yourself ready for future, right? Because the EV market of India is booming, right? And for that perception, whatever the things we is going to see after 10 years or 15 years, is will be like all around in India only. There will be a number of job will be offered to you related to EVs in the battery management system, ADAS and AutoSAR. And there will be people, the companies are expecting the people should have the knowledge about the things, right? So our today's topic is, we know, like ADAS, everybody knows. So, and please give a thumbs up who knows ADAS, like anything they have heard about ADAS and all. Yep. Okay. So we know that the people who have learned that they have the basic understanding about the embedded system, they can work very greatly, or they will be not finding any problem in ADAS, right? Now let me share my screen. Okay. Is my screen visible to everyone?
Yes, sir.
Yes. Yeah. So whenever you start your journey in learning anything, such as embedded world, you wanted to jump into the embedded world or something, try to feed this thing in your mind that the knowledge is not going to end anywhere, right? You have to keep on adding some skills, and you have to keep on adding some coding language, and you have to keep on learning from that there. So you have to make your mind learnable, right? We call it the people who will survive in IT industry or in automotive industry, who have the brain that can be trained, right? So always think in that direction. If nothing is going to you, if you will not learn anything, might be possibly you will be replaced, right? So that's why it is said to learn and upgrade yourself with anything in new technology. You have to keep on upgrading with the knowledge as well as how to configure the things in that way. Okay. Now, so this is our agenda of the meeting, right? Like it has simplified how cars see the things and make a decision. Now, before showing you I'm not a person who appreciate PPTs and all, right? I appreciate the basic breaking down the things into the more idealistic way where the people can understand. Even a fifth class student can also understand. So we know that in the embedded world, these diagrams will help you to understand everything, and you can work in ADAS also. At the end, I will also demonstrate to some of the examples using MATLAB or Python. Okay. So this is your system. This one is a microprocessor, or now we will call it as a microcontroller because it has an input as well as the output things that is together, right? That's why we cannot call it as a micro processor right now. Now, in the sensors, this is a microcontroller and the output side, right? Now, these three components will be used to develop any features in ADAS, right? Such as lane assist, parking assist, cruise control, and all. Now, how the sensor sees the world is more important, right? If you cannot sense the physical world correctly, you cannot make a decision on the things. That's why the people approach of thinking is not on this side about microcontroller and output side, but your thinking should start with the sensors. That which sensor will be best to sense the physical world correctly and accurately, right? The precision is important here, right? Now, in the sensors, we have radar, lidar, ultrasonic sensor, and camera is working as a input device. Okay. Then there is called GPS system, IMU system. Okay. Now, now, just think about, this is a road and this is your car, right? In MATLAB word, we call your car as an ego vehicle. Okay, the terminology is also important, so try to understand. And people face difficulty when they listen these types of technical words. Okay, and the other vehicles are called as target vehicle. Now this is the simple words you should remember. Okay, now configuring this sensors will help you to understand what is there in front of the my car, which is ego car, right? My area of interest is this much, right? And from there, if I can sense what is the distance of this car from ego vehicle to the target vehicle, it will be good to make a decision, to make a turning decision, or to make a to apply the brake, right? Depending upon the feature, you will make a decision, right? But it could be only possible if the sensors is configured correctly, right? Now, if you see the most important thing of this ADAS feature is the calibration of the sensors. Now, what is a calibration? So calibration is about
Hello.
if there is any changes in the sensors, that how you are appreciating that change. Please mute your mic. Now, this is the part where we calibrate the sensors to meet the accuracy, or to attain the sensitivity of the to attain the 100% sensitivity of the sensors, right? Now this term sensitivity, calibration, and all, you will understand when you will study about the sensors and all, right? But you need to remember that the physical world is being sensed by these sensors, right? Radar, lidar, ultrasonics, camera, and GPS. These two are the input device. These three are the sensors. Okay. Now, I hope it is like you can understand the importance of sensors right now, because without this you cannot implement any features in embedded world, right? So I hope you are on the same page where like why the importance of sensors is important here. Now, this is the way the car see the physical world with the help of the sensors, right? That's why it is important to understand the calibration and sensitivity mutation of the sensors. Okay, now coming ahead with the data. Now, the people who are in the field of AI and machine learning, their main task is to play with the data, right? Now, the data, human data or the sensors data or whatever the data they are providing, how accurately you can work with that data and you can mark a pattern with the data is more important. Okay. Now, what I mean to say, so see, suppose the data is coming from any of the sensors, right? So this is a particular data coming from the sensor. Now, the sensor data is being forwarded to immune from the noise which has been provided in the sensor data, right? So we need to cancel that data, right? So noise cancellation, this is not a noise cancellation of the audio or something which is you are using on the headphone or something, right? It's not like that. The noise is The data, what has been, if there is a change in the data because of something called electrical change in this or signal mutation, that will be avoided using the noise immune filters. Some we will use there. Okay. Now, when the noise is treated from the data, it will forward it to the segment of data. Now, then the segment of data is forwarded to become, it will become a feature. Okay. Now, this is the way to treat the data, right? And data is unique. Now, let's see with the example that how the segmentation and future creation, how we create the segmentation and feature of the data. Now, everybody, can you answer this one? 2, 4, 8. Mm,
16.
16, right?
128. 128.
Now,
Sir, 16, 16.
okay, because of the pattern you created in your mind, you come to know you yourself, right?
Sir, it is a bit microcontroller.
Yeah. Please, I mute yourself and
Hello, am I
mute
audible, sir?
yourself.
Yes, sir. It is a 2-bit microcontroller, 4-bit microcontroller, and so on.
Yes, yes. Yes. Can you mute yourself for a while? Okay, thank you. Now, you came to know that multiplying with the 2 will give you the result of 16, right? Now, the segmentation of the data has some pattern, right? I forgot to write here segmentation slash pattern. Now you got the pattern that the data has been muted with multiplication of q, right? Then you can predict this one, right? In same sense, when we take a data from the any of the sensors, we do this way. We try to catch the pattern and we try to add that data manipulation or data pattern is being cached and you forward as a feature, right? Now, this understanding is like a kind of very lame way we can understand the pattern and segmentation of the data, right? In the same way, this will be helpful for understanding data fusion and sensor fusion. Now, we know that we have a lot of the sensors is there in the ADAS feature, right? It will be more than 2 or 3. Now, suppose I'm talking about data fusion, and second thing is sensor fusion. Now, in data fusion, we are not specific to particular sensors the data is coming or not. We are only expecting the data from any of the sensors, right? So suppose the data 1 and data 2, we are not bothering about which sensors it is coming. Then we are fusing together and forming a pattern to make a precise action on that. So in the fusion, it is more about a diagram of this Y where we add filter, right? Here. And we filter the data as per our expectations. Okay. The way this way we diffuse the data and data fusion is being performed. Now, in this difference of the sensor fusion, there will be a different n numbers of sensor will be there, but you will be very specific with the sensors, like from which sensor you wanted to take the data. Now, so more I will speak on the left side, then we will jump into the right side about the microcontroller and output side. So when you see that the data is more important to attain the precise understanding of the physical world, so it is also important to which sensor you should choose for a particular implementation of a feature, right? Suppose you are using, everybody will be agree that camera will be used as a that you have to recognize anything in front of the your vehicle, then the camera is the best sensor, right? Or a best input device for the microcontroller. Now, every sensor come with one limitation and with one or two advantage also. Now, that's why we cannot only rely upon the camera for a particular time period, because the limitation of camera is when there is a darkness in the surrounding, or if there is a low visibility, your camera cannot recognize the pedestrian or the vehicle in front of your ego vehicle, right? It cannot recognize here. That's why we do the data fusion not only with the camera but also using the radar, right? That's why we give the importance to the data fusion, right? Because any of the feature in the DAS is has can be hazardous to the life of the driver or the passenger or the people outside who is roaming in the road, like pedestrian or the cyclist or anything, right? So that's why we need to be precise with the understanding the physical world. That's why the data fusion is very important. Now, I hope you are getting what I wanted to say. Am I clear? Thank you. Let's move ahead. Now, I hope you got the point why there is a importance of data fusion, right? Now, in the most of the cases, such as lane departure, right? To implement this feature, what we need to do, we need to keep on analyzing your left lane and the right lane, and we have to keep our vehicle on this lane only, right? Now, if I only detect the lane with the use of the camera, right, might be possible I'm driving my car in the night time. So this is not feasible, right? That's why we'll also use lidar with radar also, right? Radar has a range of almost 500 meters or more than that also it will be. Okay. Now, so see, a simple one feature where it is detecting the lane departure, that your vehicle is going away from the lane or not. You're not only relying upon the camera, but lidar as well as the radar also. Whatever the sensing, you are computing and you are making a decision on microcontroller, and then you are acting upon the output device such as actuator like acceleration, steering, and braking system. Now, this is the one example where I use three sensors, right? One, two, three. Now, let's understand the simple way of implementing that part, right? Now, see, in the microcontroller, we write a code for that to make a decision on the data provided by the sensors, and then we need to act upon the actuator side, which is output. Now, according, is my screen not visible?
It is
We
visible,
can
sir.
able to see.
Visible.
Okay,
It is
okay,
visible, sir.
okay, okay, okay. Now that's the people are trying to disturb my flow, right? Okay, no problem. Now see this one. So, so give a thumbs up if you are agree with, without the sensor data, we cannot operate or we cannot make a decision, right? Everyone is agree with that? Now,
Yes.
so with the data coming here, you need to make a decision on that particular data, right? Now, suppose if I write the code here using the while loop, yeah, thank you for muting yourself. While this is a kind of a pooling loop, okay? Oh, sorry. Now, in this what I am doing, my microcontroller is keep on sensing the data from the radar, and radar help us to find the relative distance, relative distance. And when you know the relative distance and time, relative time, can you compute speed? Yes, we can. We are a kind of smart peoples, right? Now, in this one, this is a feature we are implementing, is the feature of automatic emergency braking system, AER. Okay, automatic emergency braking system. Now, in the requirement provided to me was that to develop a system where when the vehicle, ego vehicle, comes near to this target vehicle, just less than, we can say 15, not 15, let's say 15 meter. Okay, so if it is a 15 meter of distance is there, and its speed is if the ego vehicle is speed is 80 kilometer, he have to apply the brake, right? Now, so what we'll do, we'll we will keep if here, and we will sense relative distance data with the relative distance slash d data, okay, is equal to 15 meter. Then we will use one function called apply brake, okay, like this, and we will do it. Now in this side, the depending upon the data forwarded to the microcontroller at a particular port, we are taking a data from there and making a decision. We are deciding after this that if it is equal to 15 kilometer, 15 meter relative distance data is coming, then you need to apply the brake. Now the brake will be configured at the output side, and you can see the brake will be applied. Now this is the simple understanding you should have whenever you are implementing any features in ADAS, right? This is the level of understanding you should have in your mind, because when you make anything simpler for you, you try to build an interest on that thing, and then you try to add up with the hardest concept of like ADAS and all, like data fusion and all and all. Now this algorithm is nothing but a kind of a simple algorithm we have used, but this is not simple as well, right? When we are working with the image recognition algorithm and all, there is a HSBC algorithm techniques is there. There are n numbers of OpenCV techniques in the Python we use. We use MATLAB for the calibration of the part, which I will show you in the end of this video. Okay, sorry, at the end of this class. Okay, now. So this is clear, right? Where we are expecting why the sensor has to be very accurate, because we are wanted to sense the data in the right spot. Now, now my dear friend, you have to be clear that there are in the output side, there are only two things. First is the informative approach at the output side, or the automatic. Now, in the ADAS level 1 or below level 1, we talk about giving a information to the driver that he should act. Now, here, when I'm talking about informative, I do not need to apply the brake by myself, right? I'm not confident to the ECU. I'm confident to the myself. I'm a driver, right? So what I will do, instead of applying brake, I will trigger the function called IVI warning, and warning will be there. Now, always remember, in ADAS, we will never rely upon one thing. Now, When you are giving the warning to the driver, it might be possible his eyes will be not he will be not seeing the IVI screen or something, right? We can say that, we can assume that, right? So for that, we also add a beep sound to draw driver attention to the car, right? And we give a beep sound. Okay. Now, with these two things, we provide the information to driver to act upon the things, right? But we implemented second one, or we making automatic by giving the applying the brake after making a decision on the relative distance is 15 kilometer. Okay. Now, let's move ahead with the PPT. Okay. Anybody wants to ask anything? People are raising their hand. Please.
Sir, what is noise and segment? You mentioned that. What actual factors is that?
So noise is like whenever you measure like temperature or something, because of immune things like which is data coming from the el- like electromagnetic effects in the in the wire or something, there will be a changing in the a particular data, whatever is coming will be changed because of that. So you need to immune that systems by providing noise cancellation and all that. The noise whatever is there in the data, it should be cured before forwarding to the computation. Okay, that's noise. Now segment is creating a pattern of a particular data, such as I wrote 248, and with the pattern we decided that it will be 16, right? In same way, in the machine learning, what we do, we train the decision making capability of the computer, or we can say compiler, to compile while learning it from the data provided to you. Okay. So what is the benefit of it? Sorry. Yeah, you wanted to say something?
No, continue.
Okay.
Hello,
So
sir.
that's,
Hello.
yeah, please, Sahil.
Hello, sir. What is an IVI warning?
IVA warning is kind of a screen in or cockpit, we call it. Let me show you again. So IVA is kind of a screen
सर
in
आपका
like
वॉइस
where you
ब्रेक हो
see
रहा है.
the. Okay, now it is clear. My voice is clear, right?
Yes, your
Yes,
voice.
sir.
Okay. Now IVA is kind of a screen you find in your car, right?
Sir, your voice is breaking, sir.
Right, sir. Is it a infotainment?
Yes, it's a kind of infotainment only, a screen. But we, to people who are new to automotive, just understand the screen in the car, which is where you play the music or something, you turn on the AC or everything with control. That
Right,
is
sir.
called IVA. Okay.
Sure, sir. Thank you.
Anything else? Anybody want to ask?
What what is the safety?
Sorry. Yeah, Godwin, please.
Sir, he asked about what is like safety measures or something.
Safety measures, right?
Most probably, yes, sir.
Yes, the safety measure.
Yes, safety measures. Yes, nice. So in the safety measures, that the we when we are applying the brake here, it should not be sudden braking, right? The brake pedal, this is a brake pedal, right? We maintain the degree of pressure applied here. So we keep on checking the degree here, that how much degree we are pressing, and that's the level of safety we provide to the car, right? We are not suddenly pressing it with the hard press we are giving, and we are completely turning on this one with the zero, right? So we keep on mind that the sudden braking should be not be performed, right? Because in the highway the people are coming, always there is a it is assumed that will be there, some people will be there at the back, right? Now, first safety measure is this. Second thing, when we make a when we do the adaptive cruise control, so we keep on measuring the distance, right? So this data has to be accurate. So we, for the safety measures, we do the routine self-test. Routine has to be done of every sensor before starting of the car, right? That's why you will come to know that that your all sensor, oh my god, your all sensors of that is called as routine check of all sensors. Now, before starting of car, we do the routine self check of the all sensor, that our sensor is working as per our expectation. Now, for the safety measures, we also implement fail-safe situation in the occurrence of a failure. Now, what is fail-safe? Just remember this point, fail-safe. Now, in fail-safe, what we provide, that just if any like sensors or this data computation in issue is not working as per our expectation, so all the controls should goes to driver. But that control, when we are forwarding to the driver, there should be the warning in the IVI screen that your ADAS feature is in malfunction, right? So that's, we call it as controlling of the, or we call it as safety features of a car after the failure of anything, what you are doing. Now, so this is two things we implement in the code. It's not like that you just writing the code and implementing. You have to also see the left and right, that there should be a everything is working fine or not. If not, if this one like routine check was fine, but after when you started your car, when you started your journey for 10 kilometer, you come to know that it is not working, right? There is a not like expectation level of issue is not meeting for that time period. So what it will do, it should throw the warning to the driver that you should take a control, okay, and you should decide where to go, right, or what to do. So that things is called as fail-safe situation. Okay. Now, anything else anybody want to ask?
How does that ADAS and hill can correlate? I mean, BCM hill or ALM hill.
I got it what you wanted to say. Now suppose when the feature is implemented in the ECU, right? So when you wanted to do the hill testing for this, and this is related to the ADAS feature, can you just answer me why we are using the ADAS hill? What is the definition of that?
To test the scenarios on the setup.
Yes, on the setup, when there is when we do not have the presence of the sensors and actuators, right?
Yes.
Now, as you said, I'm not saying anything. Okay. Now, see this part. When we are working with the hill setup, what we are doing, we are provided with the ECU, or we create a things in the from the vector. We create a virtual ECU here, V ECU, and from there we apply the brake, or we apply the inputs data by manual input data is given to this side, and we check that a particular decision we are making on the output side is being like, if you are expecting a 5 volt at the output side, we are getting this or not. In this hill testing, we prefer vector hill rig or D space rate, where you will see the 5 volt like a LED blink or something. So it's, if it is informative, they will find the LED blink or something. But if you wanted to see the real actuators, so you have to see the data sheet that there should be a 5 volt in that actuator. So you need to check that 5 volt is coming or not. Okay, this is a hill. Now, what about the there is a called software in loop testing. What we do,
Yes, seal testing.
so what we do in the seal, so whatever the software you have written, like this decision you have made, right?
Yes.
You have written this code. So in the software in the seal, you try to check that whatever the software, you need to validate that it's working as per the expectation, or what kind of the failure can be occurred, right? We need to check it there. Okay.
Okay.
Anything else anyone want to ask, or we should move?
I asked about how ADAS is related to what additional things will be there in ADAS apart from BCM, ELM hill.
So in the ADAS, this was ADAS issue, right? So whatever the feature you are provided, whatever the input you have to give, suppose it's a 10, like 10 meter you are giving as an input here, and you are giving the output as a 5 volt. So you need to check in the hill setup that when you are providing a 10 meter of distance as an input, a 5 volt is coming on particular port or not. This is the hill testing using the hill rig rack. Okay.
Okay.
Now you wanted to me to go more deep, I can go, but time will not permit me. So understand in this way. Okay.
Okay. Sure.
Otherwise, I am a kind of expert in automation also. I have done the hill automation also. Okay. Now, anything else anybody want to ask, or we should move with the PPT now?
Uh,
Can
can
share the
we
videos to us?
have the
Yeah, please. One by one, please. Okay.
Sir, I am saying, can you share me as a PPT with us?
I need to ask with this team, right?
If the voltage is low, I hope it's going to make it to work very well.
Sorry, Godwin. Your voice was not clear, right? So what you wanted to say, anybody?
Sir, I am saying that if you can share this PPT to us, it will get helpful for us also.
Okay, okay. I will ask from my team's member, and they will. Okay. Now see this
Okay,
one.
sir. Thank you.
Now, our topic was more into the side of the how cars see the things and decide, right? So we talk about the sensors, which is really important to understand the physical scenario of the world, right? How you sense, on which sensor to use. So when you are starting your journey in ADAS, it is my most one beautiful advice you should take. So start with the sensor. Make a notes of the sensors as stating about what is the limitation and what is the advantage of the particular sensor and what is the disadvantage, right? I gave you a simple example of a camera, right? People always say that we need to use a camera because it can recognize the people. Yeah, it's correct, but what about the darkness? What about the physical condition in which it cannot stand for, right? So that's why we should understand that what is the limitation as well as advantage of particular sensor. Now, in the ADAS revolution or a drive in the future, ADAS form the technical foundations for the autonomous driving, blending a complex electronics and software and mechanical control. Now, if you see this diagram which I shown to you, if you are the expert in embedded world, let me tell you, you will be the someone who will work with this particular features and all. Either you will be working on the sensor side calibration or mutation of the sensors, or you can work with the uh, issue part or developing the code or something. Otherwise, there are n numbers of jobs related to the testing part where you prefer doing the heal and seal testing. Okay, and there is one more testing is called mill testing, model in loop testing. Okay, now. So this is this whenever any feature is coming, they are talking about, you should draw these things into your mind: a sensors, ECU, and the output side. That's it. Nothing more than that. If you can break down the things into easiest way, you can understand anything then. Okay. Now this is our market right now. That's into 2021 there is 27 billion. In 2023 there was 70 billion. In 2025 it was 140 billion. So you can see that there is a rapid growth in the capacity of ADAS, if we can say, right? What you can expect your growth in the ADAS. Okay. Now in an intelligence cycle we see which is this is a sensor, right? Let me represent. This is a sensor, right? Which see in the physical world, physical scenario, with the help of camera feed, radar signal, lidar, or ultrasonic or proximity, ultrasonic proximity. Okay. Now, with that, we were making the decision, which is called think, right? We are thinking on that data. We are consuming, we are recognizing a pattern, and we are also making a decision. Decision making algorithm we are doing, right? Now, after making a decision, we are acting on a particular actuators by writing a code. Now, if I will not show this PPT also, you can understand the implementation part of ADAS, right? Everyone, please give a thumbs up. Now, see this part. In the sensor array, the car eyes and ears is what we called the senses. 7 senses we have. The car have a senses with the radars and lidar and ultrasonic. Like this kind of senses they have, and it is more smarter than a common man also, we can say. And one day you will find if the sensors is more equipped, then you will find with one sensor only will be capable of making a decision, a hard decision in a short period of time. Now, that's why we called MESI, who is doing the research in the field of the sensors. They have the importance, right? Now, I hope you should have gained the I have helped you all to gain the respect for the sensors, right?
Right, sir.
Now, this is the what we call decision now, which is called ECU center, right? Now, this ECU just one of the before. If you see, this is the ECU, right? But when we have started our journey, this started with the 8085 of microprocessor or FPGA kind of microcontrollers we were using, right? But that is, you should know that how to understand the architectural level of understanding you should have, right? Now I will call someone who, like, I will see that there was some previous people who have joined my 8085 microprocessor class. So Michaelo is here, right? Michaelo? Okay. Leave it. I feel he's quite shy about this. Now, in this issue in the 8085, which I teach to the student, we talk about more into the direction of that what is the architecture of the issues look like, right? How we make a decision, how we compute anything, right? So this all part where we're making a decision. So briefly, you should know that what is a part and what is the architectural level of understanding of a issue you should have. That where the data is being stored, or either in RAM or ROM, why it is stored there. This is a basic understanding you should have. Now, this 3 job scenario in the ECU side or in the sensor side or in the actuator side, the developer need to know everything about it, like sensors and the ECU approach also and the actuator approach. Now, suppose if the actuator is working upon the 12 volt and ECU rating is 5 volt only, do you think that it will work? No. You have to provide the auxiliary power to the actuators, and the decision making line where when to turn on or turn off, you have to pass to the output side. Okay. Now, This is the vision and ranging where we use the camera and lidar, right? So with that camera, you can sense this one, the how the computer see the world is like this, right? And I will show you some of the examples which I have created in MATLAB and in Python also. Okay. Now this is the way, this is the sensors we use to just understand that how it sense, how it's through its line of what is the line of interest. So there is one concern is there in the ADAS feature, that what if the line of interest is not exactly where the accident is occurring. Suppose there is no sensor is there here, right? Here, just see here. There is no sensors which is sensing. Okay, what will happen there? So that's why the the sudden like anything comes here, and ADAS will make a sudden braking will be applied. It will not going to happen that one, right? It will be a big failure for that time period. There will be like deceleration profile has to maintain, right? Deceleration profile is have to maintain decelerating kind of activity with the knowing in mind that somebody is there in my backside. Okay. Now I'm trying to explain you with the lame words, but I'm not wanting to use the more technical words to give you the burden in your mind. Okay. Now, so this all are the sensors which will be configured in the ECU, and they will be making a decision on it. Okay. Now, if you see the embedded system where we call it as this is a decision making capability, only the embedded system is not ECU is not responsible for some of the things or like that, right? But it is wrong. Everything, whatever you make a decision is on the ECU. Either your ECU is a FPGA kind of ECU or something, or either it is a DSP, a digital signal processor it is. So depending upon the requirement, you choose the particular ECU, which kind of microprocessor you wanted to choose, or microcontroller you wanted to use, depending upon the data you wanted to operate on. Okay. Now, this is the things you should know, that how many have seen like autonomous car like Tesla and all?
Yes, sir. Today only I have seen the Tesla car in Nasik.
So Tesla, why they are too accurate, because not only they are relying upon their sensors, they are also using one GPS system for okay. So satellite approach they are also using to track to have the over 360 bird view of the surrounding, right? With the satellite view of the GPS system.
Yes, sir.
Because of that, they made with the 100% accuracy they have attained, and that's why their car is now running driverless, right?
Yes, sir. But sir, I am having one doubt. Sir, the Tesla which recently have come in India, so that car is offering ADAS level, but we have to give 6 lakhs extra for that. So why it is so?
Because the cost of when you are implementing the feature of ADAS, there will be you have to increase the numbers of ECU, right? So
Sir, the Tesla Model Y uses the 2.5 ADAS, right?
Sorry.
Sir, the Tesla Model Y, which is available in India, is using ADAS level 2.5, right or not? Hello.
Yeah, please. Can you repeat?
Sir, the Tesla Model Y, which is going to be delivered in Nasik. So the Tesla Model Y is using ADAS level 2 or 2.5.
Okay. Yeah. So as I said, like level 2 and level less than 2, there where it will be kind of only informative. It's not going to be fully automatic. Now the satellite approach which they are using right now in the Tesla is not totally equipped in the India also. That's why we are not taking that part. And you know the road condition of India is not too good, because because our embankment of a road is not 100% sure, because a dog or a cow can come in between, and they might come with the accident, right? So we cannot fully automate our car for the precise, because our speed limit of a car in a highway is around 100 or 120, right? So this is the first concern, and we wanted to be more reliable upon the driver, just only providing the informative decision making capability. We are giving the direction to the driver to make a decision only, right? Just we are giving a guidance to apply the brake, to take a left turn, to do the do the right turn. Okay, this is the thing. Now, and we know that the satellite approach of there is not too equipped in India right now. It will be going to happen when their like Apple is also is investing in their maps and all in India, right? Because of that only, they wanted to upgrade their systems related to India now. So this is the like in the simplified way that microcontroller work as a brain, and we take the data, we work on the data, and we provide the things and all. Now there is a concept called V2V, V2X, and V2N. In that, what's happened? This particular vehicle will talk with another vehicle, which is called V2V. What they do, they share the information. If this vehicle is front of this vehicle, it will let me draw. If this is a vehicle here, so this vehicle broadcasts data in the server that in front of it there is a traffic or something like that, and from there it will come to know that there is a traffic, right? So this V2V communication also help us to make a data to make a decision. So at the end we can only conclude that the data, either it's coming from the left approach or either it's coming from the right approach, data will be respected. Okay, and that's why we always try to the machine learning, the people who are working in AI and algorithm part implementation, they are just trying to segregate and do the segmentation of the data in such a way that they can make a decision on a particular data. Now, one good knowledge I will share with you all: when autonomous driverless car drive for the 1 kilometer or something, around 2 GB to 2 GB or more than that data is acquired at the memory for the time being, when it's traveled to 2 kilometers something, right? So that much data it has to compute. That's why in the market we come up with the word HPC. Oh, this is a homework for you all. You need to know what is HPC, right? Now, in the ADAS simplified how cars see things and make a decision, we have them to know because of the deep learning like CNN and all. So I will show you all these things with the Python and MATLAB. Okay. Now, this is a way like how to make a decision. We collect the data, give a processing of this data and all, make a decision, then we take an action, right? This is a part. Now, which sensor to choose is our concern, right? And which software is to choose, it is your concern, depending upon which board you are using, which language they are using, like C, embedded C or C++ or Python. You need to know that, right? Now, suppose if you are using STM, so we know that STM support kind of simple embedded C, right? And so people who are studying boards, ARM Cortex and all, they know that embedded C will be there. Now Python, why we use Python and MATLAB? So we are done with the PPT and all, so which was not my real concern. I was really focused about this one things that you should understand, and you can get something from this. Okay. Now when we know that why Python is important, because the libraries it's have is more into the direction of making the decision, right? So using that library, you can make the code or you can implement that. Okay. Now, so this is MATLAB, right? Just let's show.
Sir, for
Yeah.
this ADA system, we need to learn Python also.
Sorry.
Sir, I'm saying that for this ADA system, we need to learn Python or just we have some simple knowledge of coding or that can be work also.
Simple knowledge of coding will help you because Python is not too hard. You only need to call the libraries of the Python and you need to implement. That's it. Okay.
Okay,
So
sir.
just cop up with the coding, any coding style. So either it's embedded C, C++, do. And when the person got the syntax and all, everything, what is the data type and the syntax and what is control flow and all, he can cop up with any kind of language like Java, Rust, and C++, everything. Like recently, I've also worked with the Rust also, right?
Okay,
So takeaway is like you should know the basic approach, how it's the code is going to get executed, what is the way to write, what is the syntax, and that's everything is done, right?
okay, okay, sir.
Now in this code, what I'm doing the image processing, right? I have turned on my camera because I do not want to show my face. Okay. Now wait. Let me detect let me search any pictures from Google. Okay, now I got this one. Now see this part. Because there is an algorithm called HSV where uh, the brightness and saturation and contrast of the image is rectified. That's why I have made the dark image here. Now, when I put the camera, it will give you the red sign, right? I stop, right? It has detected the red sign, right? So this is the project where we are doing the image processing from the normal Python libraries called OpenCV, right? Now it will not detect only the signal, but it will also can detect no entry sign, stop sign, as well as the signs which is provided in the height, such as left turn, right turn, avoided signals and all. Okay. This is one implementation approach. So how you feel? That was nice, right?
Yes, sir.
So
Yes, I
you can also perform these things when you know which algorithm to prefer, which to write. Okay. So people will say that I know that what I have written in the code, what was the importance of creating a black background. Because in HSV, we know that the background will be saturated and they have to be, the particular pixel approach will be taken and only that will be decided, right? And I do not want it to make my code confused about what are the surroundings, right? I wanted to make them focus on that need of my data, which is called concept of interest. I told you about this, na? Interest. This line, like where this I have drawn. My interest is in front of the vehicle, right? Now, so yeah, I will also show you one demonstration of left, what is called lens detections, using the image processing. This was also example of image processing, but using the Python. Now I have all feature implemented using the Python and MATLAB, right? So just buckle up. I will show you everything. Okay, wait. I do not. Not sharing my screen. Okay, wait for a while. Is my screen visible?
Yes, sir.
Yes, sir. I think
Yes, sir.
See this part, this is a code, and this code, what it is doing, wait for a while. It is detecting the left lane and the right lane, whatever the lines are there in the image, it is detecting, right? And it is creating. It is quite slow for a while. I don't know why it is happening like that, but as a pixel detailing is there missing. So what is happening? It's detecting the left lane and the right lane. Accordingly, it's guiding himself to run into the center of the lane. Right. This is my concept, which we are detecting the lane, and just we are controlling our vehicle to get departure from the particular this left lane or the left right lane. Now, what is the advantage of this? Now, when you are cruising at the speed of a 200 kilometer per hour, right? Suppose you are in the German road, right? It is not possible in India. So when you are in the German road, you are watching, you are just cruising with the speed of 200 kilometer. So with a little tilt of the like a steering angle, like 5 degree on the left side, you will depart from the particular left lane. So for that, it control according to the lane concept and all. Now in the highway, it is recommended to follow one lane only, and because we are knowing that somebody will come from the left side or right side and it will give you that it can crash, right? That's why it will advise to run on the particular single lane, right? With this example, we have demonstrated you the lane detections and the departure warning it will give you, right? When you departure, it will give you the warning. This is a two example I have shown you related to the image processing, which is a camera. Now I have also done many of the examples using Python also, and this one. So I appreciate all these two things because it is quite lengthy and very difficult to implement. Now, so how was it? Good?
Good, sir.
Yes, sir.
Interesting.
yes, sir. It is good.
Now we have a lot of examples I have with you too. Lot of code I have. Now this is your car. Okay, now just see this one. Now, when I will give a car, this is what I told you that ego vehicle is our car, right? And this drop red, blue is the car, and a small dot is a pedestrian, right? Now, suppose my approach is to go in this direction. And this is one is the pedestrian, all this is small dots, okay? Now this road is clear right now, right? Let it be busy now. Now see, if I wanted to go here, it will change its direction according to the to avoid the avoid the collision. It will change its path of curvature. Okay, path it will change according to according to avoid the collision with the car 747. Okay, it will change its direction. Now this is called professionalism, right? The way you code, the way you make a decision. Now decision will be there, but it's a kind of things we are making a simulation where we are not having the real issue, but we are deciding with giving the hard coded data as an input data, and we are making a decision. Okay, now see this part. See, I have decided to cross this one, but it is not crossing, it is changing its path to avoid the collision with the pedestrian 8407, right? Now, I hope you got the respect for the ADAS, right?
Yes, sir. Truly.
Now, this is the simplest thing. So I cannot show you the real, like a very complex thing to give you the burden in your mind, but these are the things which is really that very you should understand, right? Now, these all things will make you, if you are dreaming of working in the DAS, just start working with the embedded stuff, and you can in the future you can achieve your dream also. Yeah. Anybody? So want anybody want to ask, or we should need to jump with the like what is the career perspective of this ADAS?
I have doubts, sir. The example you taken recently, that is that part of
Part of a
environment, hill environment.
no.
Uh,
So it's part of only the decision making capability of ECU. He'll work with mostly on the left or right side, which is sensors and the actuators. Okay. We can say that this is a decision making capability code we are writing for this one. Okay. Now,
You were going to mention something about MATLAB.
yeah, I've shown you the MATLAB only. Na? This was a MATLAB was there, right? A lane departure, lane warning. Yeah, MATLAB से तो था ये जो lane दिख रहा था.
Okay.
Yeah, this is the one video I have imported in this code, right? And that video has been detected. Now the code is detecting the left and lane, and it is also giving the warning here. You saw red warning was there, right? So this is from the MATLAB, and in MATLAB it is quite very tough. No? It will take a lot of time to configure and do this kind of stuff. People need to be very thorough with the MATLAB options and a Simulink and all. Okay.
Okay.
So this was a MATLAB approach. Now we need to jump with a particular uh, PPT, which is called ADAS Career Roadmap, right? That what is your expectation should be after learning or getting trained in ADAS and all. So we can say that every year there is a like high paying job in automotive is ADAS one, right? Because you are working with the feature implementation now, right? And we know that with the we have predicted that on the 2030 the market cap will be 140 billion. Now there is a like impact on AIs with automotive. We can say yes, there was an impact on the automotive, but AI will not change anything, but the number will decrease. But AI will can only help the engineer to ease their task, right? So do not need to worry about that thing that your job will be taken with the AI. This is not. Okay. There should be a project in your company and that's it. Now, so you can work as a programmer in the ADAS and you can develop your code algorithm. You can be a protocol engineer where you are configuring the port protocols like CAN, Ethernet, automotive, and Lean. So you should know this part when you wanted to work in the automotive. Okay. So you should know the Linux. You should also know the robot operating systems. It is really standard for the prototyping autonomous features. Okay. Now, if you see this part, so accuracy of data, how I was acquiring the left lane and the right lane, it was not about only deciding with one algorithm. It was a set of 3 algorithms we have used, which was we can say Kalman filter is my favorite, where it's filter the required data, which is very important in ADAS. And for Python, I use OpenCV and DIYtorch. Okay. Now, in algorithm engineers, you can work as a developing an algorithm. Perception engineer, where you are deep in expertise in computer vision and deep learning of a compute like compiling and all, how to make the perception about the things. And the system architecture, like when you decide the requirement of the any ADAS feature, system engineer pop outs first and they decide what will be the feature there, right? Now, in the ADAS simplified, how cars see the things in this in this PPT, you will see key job roles. First of all, we call about just simplifying this common words. First is the validation, where we talk about hail, seal, and model in loop testing. In the test driver, like an operator, where you can be also getting a job. So when I was working in a seed for a particular time period, so there was we have worked as a validation engineer for a time being, and then for a calibration engineer also. So in calibration engineer, we try to give a calibration to the sensors and all. Okay. Now, so you can see there are n numbers of jobs is there in the ADAS. Now, what is your expectation of a 5 or 10 year in the ADAS, right? You can expect yourself that with the perfect knowledge in this, you can reach up to level of CTA. Okay. Now, and you can start learning by starting with the simple embedded protocols understanding, and then you can try to add more upon the tools uses like MATLAB and Kanoi tools, like how to do the calibration using the CANAP. It's a vector tool. Okay, so this is the things that you should know about ADAS and what is the expectation you should have from yourself after getting trained or after getting the knowledge in ADAS. Okay. Now, anybody have any doubt or anybody want to
Yes,
ask? They can.
yes, sir.
Sir,
Sir,
I
can
have
you
a
hear me?
question.
Hello?
Yes.
Sir, can you hear me?
Yes. Yes. Please.
Hi, sir. Sir, I'm planning for a startup, AV diagnostic and ADAS calibration center like that. So how can I design my roadmap? So,
So you
this,
add me there. I will decide everything for you. Okay.
okay. So how can
Thank you,
connect to
sir.
you? Sir?
You can connect me. I will give
Oh,
you my number afterward. Okay. Azhar.
yes, sir.
Sir, I have also a question.
Yes, Sanjay, please.
Sir, I'm having over 6 years of experience in data analyst role. So what will be good for me, sir, in the
Data
ADAS?
analyst.
Yes,
What
sir.
was your role?
The data analyst.
Okay. So yeah, so you should know that whatever the data you are consuming from the physical world, so there are many words, which is a precise word I'm not remembering. So which one to filter out when which one to take, right? So when a camera is on, it's continuously each and every pixel is being processed, right? But
Yes.
where is your area of interest? The data analytic will decide, right? Where you should focus. Suppose I have turned out my light and that I only shown the traffic signal to it, right? Because in my code, I know that I have not coded to bifurcate everything or just focus on the pixel of a signal light, right? That's why I have turned off my light, right? In the same way, the data
Mm.
analytics decided at how they can add the filter to avoid this all dummy data which is not required. A data which is not in our use, it's a dummy data, right? Sanjay?
Right. Yes,
So
sir.
yeah, so Sanjay, you'll be happy to know the data analytic are more in number in the ADAS. Really.
Okay, sir.
Anything else?
Understand. No, sir.
Any?
Thank you, sir.
Hello, sir.
Hello, sir. Hello.
Sir,
Hello.
Yes, I is.
Yes, sir. Currently, I am doing electrical engineering diploma. So, can you give me the further roadmap for the EV career?
Electrical engineering, right? After 10th, you're doing
Right.
diploma, right?
Yes, sir. Yes, sir. After 10th.
Keep on learning. That will be my advice. And please have an interest on embedded and respect the concept and try to understand all things and try to work on protocols, try to develop. When I was there in my btech, when I was there in, so I used to work with the what my project was related to underground fault detections in the second year I have developed. So the crux is when you work with the hardwares, you come up with the many ideas, right? So that
Yes,
is
sir.
very, yeah. Anyone else?
Sir,
Thank you, sir.
I'm doing a similar kind of pathway. Like I'm doing my MTech in power electronics. So it's the same as you said, sir. Just keep studying.
Power electronics, right?
Yes, sir.
Okay. So for the power electronics, keep on studying will not work out. You just try to look into the. You have done your masters, BTech, right?
Yes, sir. Yes, sir.
Yeah. So if you wanted to grow more, if I will ask you right now to just make a circuit diagram of DC-DC converter, buck boosters and all. So if you
Yes,
can
sir.
do it, right?
Yes,
So
sir.
in that level you have to reach, right? You can do it, and you can also show them how it is working. What will be the diagram of output when the input is this or that, right? So try to reach on that level. Okay.
Yes,
Buck
sir.
boost converter, inverters, you should read all these things.
Yes, sir. Sir, is there any way we can reach out to you? Are you available on LinkedIn or
Yes, sir.
LinkedIn I
Could you
cannot
please
share.
share your contact number, sir?
your LinkedIn links would be helpful, sir.
I cannot share my LinkedIn. Sorry.
Okay, okay, okay,
I
sir.
will can share my email ID. People who want to connect there, please do not trouble me or something. Okay.
Sure, sir. Sure, sir. Sure, sir.
Hello, sir.
Yes, please.
Sir, could you, sir, could you provide us with a software-oriented approach for this? I mean, for this domain, because say someone like industry from a mechanical engineering, how will he shift from his mechanical knowledge plus with the software and hardware knowledge? How will that shift take place?
Okay. So whenever we call a carrier shift from the mechanical to other particular any other domain, right? So first of all, do not give excusing word to your mind that I was from the mechanical, then I jumped to this, and I cannot cope up with the things. First of all, try to avoid this kinds of a statement to your brain. Okay, okay, Rohan. Now the second thing is the success of embedded engineer is not about only understanding the basic knowledge. It's about improvising yourself day by day with a particularly understanding the protocols, coding style, and everything. Okay. Do not share your email ID, please. Please, I have shared you my email ID. Okay.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Okay. Now, so that's why you start with the 8085 microprocessor because this is a basic where you understand about the things, how the things are being executed, and then start with the coding, then end up with the all the things. Okay.
Okay, sir. Thank you, sir.
Now, advantage of the mechanical in automotive is that they can understand the understanding level of the body formation, like ladder shape and these all things which is required, chassis, body domain, and all. They can work there also. They can contribute their knowledge there also, right? So there are people who is working with the mechanical. They are working in the automotive, and who have asked me about the power electronics. So I wanted to add one thing. The PMS about the buck boost converters and inverter and DC-DC converter are there. So people are doing the R&D in that field also. Okay. So you can work in that domain if you have the interest in power electronics, and you can accept a good package also.
Yes, sir. Yes, sir.
So I hope you are all happy with the content which I have shared you all.
Yes, sir.
Yes, sir.
Yeah, anything anyone wants to add?
I have one question. I have 6 years of experience and I'm working on embedded C and MATLAB mostly. So in MATLAB, currently I'm just working on Simulink and Streetflow. So considering ADAS, how important .m scripting would be? Is it necessary to learn that?
You saw my .m scripting, right? That's why you concluded that .m is important or something like that.
Yeah,
But
yeah.
it's not like that. So, the MATLAB is quite easy for those who know how to do the cheating, right? Because when you open the MATLAB, there are n numbers of like block sets are there related to the examples of ADAS features. In the simulation, when we are designing the MBD, model-based development ADAS, okay. But in the scripting part, you have to write every line of code by yourself, and you have to do the execution part. Is
Right.
not any function will be there. So start working with the .m or something. But if you have the good knowledge, use both. Use MBD also. Use Simulink also. Use Simulink. Sorry, use .m scripting also. Okay, Gus?
Okay.
Yeah. Yep. Anybody else?
I
Mm.
hope that everyone has asked their questions and shared their queries. So, could we end it now? Like, can move ahead. Saurabh, Mr. Saurabh, do you want to share anything with our learners, our students?
Uh, I hope I'm clear with whatever I said, right? So everybody is clear what I wanted to share their information about the DAS. And so people, I have also solved their doubts also. So yeah, we can wind up also, no problem.
Okay, so everyone's query got answered, and so before moving ahead, before closing the session, I have shared one link in the chat box. From there, I'm sharing it again. From there, you can generate your certificates, right? So here is the link. I have shared it in the chat box. You could go and generate your certificate. Meanwhile, I'm giving a thank you note to everyone. That at the very first, thank you everyone for your active participation and joining us today. And a very special thank to Mr. Saurabh for having a wonderful session and explaining each and everything, connecting each and every dot, and simplifying ADAS and showing us how these technologies are shaping the future of automotive engineering. Right. So now I hope the session guides you towards a clearer, more confident approach to EV, ADAS, and AutoSAR careers. Okay. So with
Actually,
that note, with that note, I would like to take a goodbye for now. Stay connected for upcoming sessions. Ask your friends to join. Bring your friends in, and let's make a more holistic community for upskilling EV. Because we are the future of electric vehicle. Yeah, right. Thank you everyone again.
link is
Thank you
not
for this.
working well.
Yeah, yeah. Bye. Your your certification have been generated from there, and also if you want to connect with us, there is a phone number and the email ID has been shared with you in the chat box. You can directly connect with us. We are available. There's nothing to worry. We are here to help you. Right? So there is anything like that.
Was not
Also,
working well.
cheat sheet presentation which was presented by Shora will be delivered if you have filled the attendance form, and we will certainly announce who will get the opportunity to have a one-on-one session with Saurabh, right? So if someone is going to get the opportunity, obviously we will mail him. Okay. So thanks again for joining, and have a good night ahead. Bye bye.
Thank you.
Thanks
Bye.
once again.
Good night, sir.
Thanks once again for having a great
Thank
session.
you. Thank you. Thank you.
Thank you, sir.
Hello?
Yes, bye everyone. Yeah, Sanjay, you wanted to say anything?
The link was not working.
Okay. Yeah, like those who wanted to connect me on the email, they can message me there. Okay. And have shared you my email ID. Okay.
Chat, what you can do for the link? Link is not working properly. It's not opening also.
No, no. What I can do, I don't know. I don't know which link you are talking about also. So thanks for you all. You're making my like copying up with thanks for copying up and all. And you also like you appreciated me a lot, right? So that's helped you a lot to get always get motivated and all. Thank you everyone, and stay connected, and let's grow together one by learning everything. Let's see what's happened next. Okay, bye bye everyone. See you in like some of the people are from my class only. I can see like mm, uh there is was Michaelo is here, right? Michaelo? Yeah, yes, he's here. So people are there. Yeah. So Michaelo, it was good. You understood the thing?
Yeah, it was informative. It was good. At least it was nice to have an introduction to how vehicles think when
Yep.
when they're being driven. So that was really good.
Yeah. Thank you for attending this webinar. I will see you in the class, Michaelo. Okay. Bye bye. Have a good day. Okay.
Sure.
Bye.
Thanks. Bye. Same.